Well, good evening, everybody. My name is Dan Kelting. I am the Executive Director of the Portsmouth College Adirondack Watershed Institute. You can see, should see three of us on panels. With me tonight is Zoe Smith, who's the Deputy Director of the Watershed Institute, and also Dr. Curt Stager, who's our featured speaker this evening. I'm going to say some more about Curt in a minute before he launches into his talk. Really excited to have this many people participating in our inaugural Water Week. We actually have over 200 folks registered for the various events that are happening through the week. And just if you are first logging on to, this is your first presentation for the week. This is a one-week event. It actually started yesterday and goes through Friday night. And this is an event that is hosted and organized by the Portsmouth College Adirondack Watershed Institute and also Northwood School based in Lake Placid, New York. And this year it's a week-long live virtual speaker series. And hopefully starting next year, it will be more interactive and in person and based in the Northwoods hub in downtown Lake Placid. So this is day two, and so I spoke last night, and now we have Dr. Stager speaking about climate change in Adirondack waters. Then we have four more really good presentations happening. Meg Moldley tomorrow night will talk about aquatic invasive species. We'll have Dr. Danielle Garneau from SUNY Plattsburgh talking about microplastic pollution in Lake Champlain. Then Brendan Wiltsey from the Adirondack Watershed Institute will talk about road salt contamination in Mirror Lake watershed. And then we're going to conclude with a guided discussion facilitated by Zoe Smith from the Watershed Institute on community action to protect clean water. Starting yesterday with my talk and continuing through Curt and the others this week, we're going to hear a lot of concerns about the future of our fresh water. But there is a lot we can do locally to protect our waters. And so the final night with Zoe is going to be focused on what resources are available and what actions you can take locally to protect your waters in your region. So we'll culminate with that series of stories of action and the discussion about action. All of these talks are being recorded. So meaning if you do miss a session and you want to go back and look at one, we will be posting them onto our website as soon as we can figure out how to do that. But they are being recorded, and so you will have the opportunity to look at the talks at your leisure at some later date. And when they're all available, or when they're available, I'll send an email to everybody that's registered for the event, so you know where they're located and what's available. So before I introduce Curt, I'd like to turn it over to Zoe, who's going to talk to you about how to ask questions of Curt while he's giving his presentation.
Great. Thanks, Dan. So there's 67 people on. This is fantastic to see everyone joining in tonight. So you are able to submit a question at any time this evening, and there's a couple of ways in which you can do that. The first is through the Q&A function on Zoom. So if you're not familiar with that, if you look on the bottom of your screen, you'll see a Q&A icon. If you hit that, you can submit a question either anonymously or you can include your name. Dan and I will be monitoring those, and we'll facilitate that question and answer session with Curt at the end. The other way you can do it is through the chat function. And so also on the bottom of your screen, you'll see a chat icon. And there you can hit that and you can ask a question there as well. So we'll be monitoring both of those. If you're using an iPad, your icons might be at the top of your screen. And so either at the bottom or at the top, but we can't see you, we can't hear you. So don't worry about muting your line. You'll just be able to see actually just Curt and his screen very, very shortly. If you can't figure out chat or Q&A, you can also raise your hand. There's a raise hand icon also, and we'll connect with you and make sure that your question is submitted. If you're having any technical problems, I'm going to put my email into chat, and so you can email me and I will do my best to help you, or you can just chat right to me. So with that, I'll hand it back over to Dan.
Thank you, Zoe. So then at the end, So I'll be monitoring the chat through the duration of Curt's presentation, and at the end, I will facilitate a discussion, basically pulling questions out of the chat and asking them of Curt, and he'll be responding to your questions and comments at the conclusion of his presentations. Curt, why don't you go ahead and share your screen?
All right.
See if it works.
Yeah, let's hope.
Well, while Curt's doing that, so it's my pleasure to introduce Dr. Curt Stager, who is a professor of biology here at Paul Smith College. And Curt holds his PhD in biology and geology from Duke University. He's a specialist in paleoclimatology. Curt has been a very productive and prolific scientist. He's a very talented writer as well, for general writing as well as scientific writing. He's published over 30 peer-reviewed journal articles in some very prestigious journals, from Proceedings of National Academy of Sciences to the journal actually called Science, which is one of the premier journals in the world. He's also a very well-known author in the normal press, if you will. So he's published in National Geographic, New York Times. He's written 4 books, and so he's really been very productive that way. He's co-host on a beloved radio show that's hosted every week called Natural Selections on our very own North Country Public Radio, which is also syndicated nationally. So many people know Curt through that particular interaction. A couple of books I want to note that Curt has published that are, I think, germane to his talk tonight. The first one is Deep Future, which is the next 100,000 years of life on Earth, which is a pretty compelling title. But I think that speaks to Curt and his interests and his deep thoughts, right? And he thinks long term, like a geologist. I think a geologist would do that. And then his most recent book is Still Waters: The Secret World of Lakes, and I think that kind of blends in well with his talk here. And so with that, I'm really delighted to turn it over to Dr. Curt Stager to talk to us about climate change and Adirondack Lakes.
Great. Want to make sure everybody can hear me, Dan, or anybody want to just chime in real quick, make sure my microphone's working and everything?
I can hear you fine.
Got it. Okay.
Yeah, I hear you.
Right. All right. Thanks so much for that introduction, Dan. And it's a real honor and a pleasure to be part of this Water Week and to help showcase the Watershed Institute. When I first came here a billion years ago, we didn't have real active science involvement in the community on the scale of this. And it's a real credit to Dan, what the Watershed Institute has become. And I'm just really thrilled to see this kind of outreach happening, not just in our community, but it looks like it's almost global. Here we go with the Zoom thing. So I'm just going to dig right into it. Dan asked if I could sort of summarize what climate change is doing here in the Adirondacks and what that might mean for lakes. So that's exactly what we're going to do for about the next half hour or so. So we often think of climate change as something that happens far away with polar bears and sea level rise and things like that. And that's, of course, happening. But we also have it happening right here on our doorsteps. And that's very well documented in a lot of ways. A lot of the folks listening tonight and the folks we know around here are keeping tabs on these kinds of things. But as far as the climate goes, we've got 6 reputable United States Historical Climatology Network weather stations here in the Adirondack uplands, mostly here. Their data are updated regularly and are pretty reputable. And so I've been compiling those data from year to year and get a general picture here that I'm going to share with you in terms of temperature and precipitation, showing that we've got pretty big changes going on here, just like the rest of the world. So, for example, here's a century-long temperature record from the Lake Placid weather station. And without getting too much in the nitty-gritty, although there have been ups and downs over the last century, there's a pretty clear-cut trend of warming going on. In this case, it's like 3.5 degrees Fahrenheit since roughly the 1970s. mostly in December, January, February, and then July, August, September. So winter and summer are seeing the biggest changes. That's on the scale of the global warming, maybe even a little faster. So it's a real thing. It's really happening here, especially in the last 3 to 4, 5 decades now, half century it's getting to be. The turning point was around the 1970s. So the bottom line for that then, where we live, is our milder, shorter winters are starting to happen, and longer, hotter summers. They'll, of course, differ from year to year, but the overall trend, not of the vagaries of weather from month to month or year to year, but the overall trend of the climate is clear. This kind of thing is happening all over the Northern Hemisphere and globally as well. So for us to have shorter, milder winters, of course, has cultural implications as well. And I won't be getting into that too much, but it's pretty obvious. A lot of the character of the Adirondacks is centered around what happens here in winter, anything from the Olympics to the winter sports and things like that. But I'm mainly going to talk about what's happening in the warmer months with the lakes. Apart from this, we have people who have written down when lakes freeze and when they thaw in the spring. In this case, this is a 200-year record from Lake Champlain, where people have been writing down when the lake froze up. And this is the kind of central basin between Plattsburgh and Burlington. So it's called the main basin of the lake. And this has been done basically through generations of volunteers, pretty much. I've tried to simplify the timeline here, going from left to right. You're in the early 1800s when the record started, and they continue today. And I just put a little asterisk down on the timeline for every winter when the main basin of Lake Champlain actually did not freeze over completely in that winter. So on this timeline, if you read from left to right, you've got 1, 2, 3 winters, or actually not even that, in the 1800s when the lake didn't freeze totally. And then they start to pick up more and more and more until it's just loaded with asterisks. And it's basically now normal on average for the main basin of Lake Champlain not to be frozen. That's a pretty clear indication of a warming trend. But we've got data from our own lake here too. It's actually easier to find records of when the ice goes out, because of maybe something psychological for people, I guess. If you had a long winter and you're eager for spring to come, everybody is watching. Plus, people gamble on ice out contests, and there's money involved. So people are pretty meticulous about it. They keep written records so that you can maybe predict next year's ice out based on what happened before. So we've got actually early records on Lower St. Regis Lake, where the college is, going back to the early 1900s from the days of Paul Smith's Hotel. But it's been kept more regularly since 1970 by various people, and my students and I have been maintaining this. And if you look at those trends since 1970, the lake is not only freezing up later, which would mean warmer autumns and summers probably, but also the ice is leaving earlier, a little more than a week on average. So we can see this happening in lakes all over the region. But here's just some examples from our own lake right here. So the one speculation for why that would happen, of course, is, well, maybe if the summers are getting longer and hotter, maybe the lakes heat up and it takes them longer to cool down. And that could delay the freeze up. So we have a little bit of evidence that that may well be happening. For the last 30 odd years, we've built a research program into the introductory biology class, where we send the students out to the point on the campus and they drag a plankton net through the water every week and find out what's living in the lake and watch the succession of species through the season. But they also take the temperature, and we've got those records going back to the 1990s. And just as you might expect, with the warmest time of the year actually being in September, we see an increase in surface temperatures there at the point, collected by generations of biology students, from an average of about 13 degrees centigrade in the 1990s to closer to 18 nowadays. So that would fit with what the weather stations are saying. Here's a lake getting warmer on the surface. Now that has implications, of course, for lakes. If you warm the surface you make the water more buoyant, and it actually floats on top of the deeper, cooler, denser water down below. So you get temperature-based layering of a lake, just like geological strata. So the technical term for that is thermal stratification or layering. And seems like it was more or less discovered, interestingly enough, in the 1800s, at least in the United States, by Henry David Thoreau, whom we often think of as a philosopher rather than a scientist, but he was actually both. And in the book Walden, if you've ever read that, there's even a quote in here that he wrote down after he lowered a thermometer in a bottle down to the bottom of Walden Pond and let it equilibrate and pulled it up. And he could measure that the bottom was much cooler than the top. And he said, what various temperatures the fishes of this pond can enjoy, they can in a few minutes sink to winter or rise to summer. So this stratification changes through the seasons, and it affects the oxygen concentrations at different depths in the water, and also affects where fish can live, partly because of the oxygen and partly because of the temperature. So I was just showing with these illustrations here on either side of Thoreau on his pond there, you've got more spread out conditions here where the fish can go, but as the lake stratifies and stabilizes over the summer, they can tend to sometimes be concentrated in the upper part where there's more oxygen, or in other cases, if there is oxygen down below, they may hide down there to get away from the heat. This will have implications for lakes going forward as the summers continue to get longer and hotter and the winters get shorter. So one example of this is, I think, pretty inspiring. This is an example of long-term thinking and building climate change into strategies for managing lakes and fish in the Adirondacks. This is being done by the Nature Conservancy with Follinsby Pond over near Tupper Lake. And this is a very deep lake, and it stratifies in the summer. And it's got a large oxygen reservoir and a reservoir of cold water down there that allows lake trout to survive long, warm summers. So this lake could well be managed as a lake trout refuge in a warming climate. As we lose lake trout and possibly brook trout as well in other lakes that don't have this large, deep, cold, oxygenated reservoir through the summer, they are fading out in other lakes, not only in the Adirondacks, but around North America as well. So building climate refuges into management plans, I think, is going to be more and more important as we go forward. So climate's not just temperature, of course. You have precipitation, and the precipitation trends are changing as well. So this is again from those 6 weather stations, the last century of total annual precipitation in the blue line. And we've also got a wetting trend going on since about the 1980s, especially since 1970s in particular. So it's been getting not only warmer, but wetter around here. And that affects lakes as well in ways that are easy to see. So to get back to Lake Champlain, there's a lake level gauge on the King Street dock in Burlington, and you can collect those data offline and plot them against the precipitation. And I've done that on this graph here with ups and down bounces of blue. That's the precip, and the black line is the level of Lake Champlain. And not surprisingly, they match pretty well. Since about 1970, we've gotten about 3 inches more precipitation per year, and the level of Lake Champlain on average went up about a foot. So there's a direct relationship between precipitation regimes and the levels of lakes, which then have direct implications on ecosystems and people that live around the lake. So you may remember some years ago, we had a pretty wet spring. Was it 2011, I believe? And Lake Champlain just flooded its banks because it was so wet. And that was a major problem because a lot of the marinas and launch points for putting boats on the lakes in the spring, on the lake in the spring, were flooded. You couldn't use them. So it was interesting that you'd think if it was a big flood time for a lake like that, there'd be tons of boats everywhere. It was actually like a ghost town of a lake because people couldn't launch their boats. But what was even more important for people who use the ferry service was that the ferry service there in South Burlington had put their office right on the shoreline of the lake. And when the water came up, it flooded their offices. So The people running the ferry service still had to do it, and they would commute to work in rowboats. And when I visited after that, they shared some photos with me. Here's one inside their garage workshop. And they had to work in, rubber boots and then waders and then chest waders eventually in frigid cold water for day after day after day. But what I thought was even more striking was what I saw when I went there without the water in it. And it's this back wall here behind this fella. Right about where that line is on the wall, if you go to this building now, you'll see a black line that the workers drew onto the wall to show how high the water came. And they put a date on it. But what's even more interesting than that in terms of climate change is below that is another line with an earlier date on it. And below that is another line with an earlier date. And you can see that when you get an unusually wet spring, Lake Champlain not only rises in response, but it's rising more because the springs are getting wetter as well. The wet events are getting wetter. And that's all part of the global trend too, at least in the Northern Hemisphere. So in addition to the lake level going up, with those kind of easy to see impacts, there are other things that go on when you get a wetter climate as well. And that's because the lake is fed by runoff from the surrounding watershed. And the more runoff you have, the more erosion from the flooded rivers and the sheet wash coming off the land. That will carry sediment, sometimes from farms that'll have fertilizer or animal waste on them. But even the sediment itself, just forest soils or others, often contains phosphorus and nitrogen and things like that, that gets washed into the lake along with the sediment. So in this 2011 spring floods, we saw big plumes of sediment washing in from the Au Sable River and erosion of the headland from the high water stands here in another region. That has ecological effects on the food web of the lake. So here's boating here near Split Rock near Waylandsburg, New York. In June, after the flooding had subsided, you can see where the water level was. But look at the color of the water there. It looks kind of like pea soup. So when the lake turns greenish like that, that's from things living in the water. And in this case, it's microbes, a mix of green algae, probably some diatoms, and also cyanobacteria, all of which you'd put together and call plankton or phytoplankton. And those were responding to the big slug of phosphorus that was washed into the lake during the flood season. So this changed the clarity and the productivity of the water even after the rains subsided. So you can see the effects of these climatic shifts happening in other lakes around here, actually up in the uplands, smaller lakes. A lot of us at the college have spent quite a number of years studying Bear Pond, which is a few canoe carries away from Lower St. Regis Lake, where the college is. So I'd like to just fill you in on what we see when we go to Bear Pond now compared to what we used to see in the old days. Some of you may know this pond. It's really beautiful, partly state-owned, partly private. In the old days, it used to be crystal clear. It's not so clear anymore. And in the old days, it also used to have a little island. If you carried in from Upper St. Regis Lake with your canoe, you go through Bog Pond and then carry into Bear Pond. And then you veer over to the left. There used to be a little grassy island with a DEC no camping sign on it. I knew it well. I admit now, decades later, after the statute of limitations runs out, that I camped there illegally with a guest and was arrested by a ranger. So if you go there today, the tree with the no camping sign is still there, but there's no island anymore. The water level has come up, and actually this summer, some students and faculty and I went over, and the tree has now fallen over, so that's not even there anymore either. If you go to the shoreline of the lake, here's near the carry where you put it in out, you notice these tree roots are going under the water there. Trees don't normally take root underwater. If you see something like this in a lake that you're visiting, and it basically means the water level has come up since the trees have taken root. So these are changes due to the climate trends that show up in the weather records that you can see with your own eyes and experience on the ground just by visiting our lakes. So But here's what I was referring to about the clarity of the water. Those of you that might have known about this lake years ago might remember it as clear as a swimming pool. It was this gorgeous aquamarine blue. You dip your paddle in, it's as if you were dipping it into air. You could see tens and tens of feet down to the bottom and see plants growing down there. It doesn't look like that anymore. It was this beauty that would draw people to bring friends like I did to say, look at this gorgeous pond. Well, it's still pretty, but it looks more like this today. The clarity has been reduced by about half. So it's still worth going, but you don't go there to show off this beautiful swimming pool clear water anymore. And that's because some things related to climate have happened to this lake. One of them actually is not so much climate, but it is a human impact that's sort of related. One of the effects of burning fossil fuels is not only warming the atmosphere, but upwind of us, especially in the Ohio Valley, places like that. Burning fossil fuels, especially in the old days, released a lot of sulfur oxides and nitrogen oxides. And they would blow from west to east, hit the Adirondacks, and fall out and in what we would call acid rain. So that was one of the reasons why Bear Pond was so acidic. Brendan Wiltsey and other Paul Smith's people and I have been studying the history of the pond there and can actually document how after the EPA enforced the Clean Air Act from the 1990s, the pH of rainfall in the Adirondacks has switched gears, is no longer acidifying so much, and the pH or acidity of this lake has been recovering. So here's an environmental success story of controlling that aspect of fossil fuel burning upwind of us with sound laws that didn't wreck the economy and did a lot to help address this problem. So seeing Bear Pond not so spectacularly clear anymore, well, you know, that's maybe a worthwhile trade-off to get it kind of back to normal. But there's something else going on too. And this is happening in especially temperate zone lakes here in the Adirondacks and elsewhere. It's called browning. And it's basically what happens when you combine the recovery from acid rain with climate change. If you stop acidifying the forest soils around the lake, you allow microbes to recover and start breaking down organic matter that used to be there in the forest, but was kind of sterilized by the acids. So that then is often brownish in color and starts to wash into the lake. If you're also warming the climate, it speeds up the metabolisms of these microbes and it breaks down more and washes in. And then if you're also making it wetter, the water runoff seeps in and carries it out as well. So it's pretty much like dipping a tea bag into a teacup. The tea bag contains organic plant matter and has these tannins and other compounds, organic matter in there. It's basically what you're doing then on the scale of lakes is making forest tea with the recovery of acid rain combined with warming and wetting. A lot of lakes are no longer as clear as they were because they're getting browner. And then finally, on top of that, you can also get more plankton of certain types growing in there, and they have their own colors. In the case of Bear Pond, it's not so much browning. In fact, I'll flip backwards here. It's not so much browning as greening. And so we're getting kinds of phytoplankton that weren't so common before are starting to show up. And it's pretty reasonable to assume that the climate change has something to do with that as well. So this set of boxes here with the arrows is meant to sort of summarize the most basic overall effects of precipitation changes and temperature changes on lakes. So in this upper part, we get stronger storms or wetter climates, you get more runoff, more nutrients washing in from the soils, that feeds algae. Same thing, if you warm the lake, you warm that upper layer, it makes a lid on top of the deeper layers, and that can contribute to algae blooms as well. And I'd like to show you the basics of how that works in addition. So if you stratify a lake in the summer, you get the warm upper layer that you might enjoy swimming in, you kick your feet down into the colder layers, you can feel it. But way down on the bottom, it can be many degrees cooler. So over time, the bottom layers being isolated from the atmosphere and also too deep for algae to do a lot of photosynthesis and no weeds or anything, you can start running out of oxygen down there. So by the end of the summer, from a well-stratified lake, there are not only temperature differences, but oxygen and other chemical differences between the top and the bottom. You can see that if you study the sediments under the lake. So Brendan and I and students do a lot of coring of sediment layers under our lakes. And oftentimes when we lower a weighted tube down to the bottom of a pond or lake and pull up the sediment layers, we'll often see it darker on top and lighter color sediments down below. The color of the sediments will often tell you about the oxygen conditions in the lake. Let me flip ahead here. If you have plenty of oxygen down on the bottom, the oxygen in the water will brush against the sediments on the very surface of the bottom of the lake, surface of the bottom, the top layers of sediment. And because there are often iron minerals in those mineral grains, in the sediment grains, the oxygen will rust them and give you ferric iron here, which is visibly rusty in color like that. But if the bottom layer or the hypolimnion of the lake has lost its oxygen supply, this won't happen so much. You can actually reverse this. The oxygen can leave the iron or just not rusted in the first place and leave the sediment dark instead of rusty. So this actually has major ecological implications for a lake if this sort of thing happens and then continues for more and more time. So I tried to figure out a way to illustrate this. So what I've got over here on the left, the lower left, is a column of sediment. It's actually sediment core with lake mud, and I've drawn a red bar across the top, and that would be the rusty layer. If the lake is clear and cool and well mixed, oxygen's getting down there. It's trapping things down in the deeper sediments. There'd be iron in there, of course, but also phosphorus and other nutrition from the dead algae, dead fish, and things. It's basically like a lid holding the nutrition down in the sediment as long as there's plenty of oxygen in that lower layer. So if you stratify the lake and you're starting to lose your oxygen supply down below, that rusty cap can dissolve away. The iron goes into solution. And now you've taken the lid off the sediment, and things in the sediment can start dissolving into the water as well. So if phosphorus starts going in, you can start fertilizing the lake from within. Even if you're not washing a lot of fertilizer or sewage or anything like that in from the surroundings, the lake itself can internally fertilize itself because it's been stratified for a long time, lost its oxygen supply down below. And if that happens, those nutrients, the phosphorus and others, can work their way up through the layers, get up to the surface where the sunlight is, and trigger cyanobacteria blooms, algae blooms, basically this process called eutrophication, where you increase the growth and productivity of the plankton, which can oftentimes have undesirable side effects. It's possible, maybe likely, that this process is playing a role in the story of Bear Pond as well. So there you have it. We've got climate change happening here. It's getting warmer and wetter. Winters are getting shorter, summers are getting longer. Lake levels are going up, browning is happening, recovery from acid rain is happening. We can speculate about what's coming next, and basically, it's pretty likely we're going to have more of the same. We're releasing fossil fuels still, and they are changing the world's climate. There are multiple climate model projections of what could be happening around here. Mary Thill and I did a study some years back for the Nature Conservancy, running 16 different climate model scenarios for the Champlain Basin and this part of the Adirondacks. And basically, part of the story is going to depend on what we do. If we cut back quickly from fossil fuels, we'll have a moderate warming. If we continue as we are now, it'll be extreme. Different models give different ranges of warming. I've got some here, but the basic story is they all say it's going to get warmer for the rest of the century. And how much we emit will determine how much warmer. So as far as the precipitation goes, that's not as easy to predict, especially in a complex terrain like the Adirondacks. In the moderate case, moderate emissions, it looks like maybe little or no change. But if we do increase fossil fuel emissions a lot, it should get wetter as well. So the bottom line for this is if you're interested in lakes, and especially if you're responsible for them and studying them, like people at the Watershed Institute and elsewhere, you're now running a race against climate change. It's kind of like the situation in Alice in Wonderland, where the Red Queen is dragging Alice along here, and she's running and running, but staying in place. And she says something along the lines of, you have to run as fast as you can to stay in one place. And it's kind of like that. If you want your lake to stay the same, you've got to aggressively manage it to resist the changes that are underway because of the ongoing climate change in the background. So I'll wrap up with a case study here of a lake that means a lot to some of us here who do this kind of research. And it's treating our most remote untouched lakes as sentinels of these changes to warn us that these very things are starting to happen that might be obscured in other lakes that have more impacts, and it's hard to tell what's causing it. If you can have a control system or a sentinel system that does not have a large number of impacts, if that starts to change, you know something's going on for the whole region. So here in the Huntington Wildlife Forest, there's an inaccessible protected lake called Wolf Lake. It's never been acidified, never been stocked, never been reclaimed, limed, or dammed. It's protected with a gate by SUNY ESF. And we were invited years ago to just give it a look and see if it might be unusually pristine. Some students and I put out some nets and caught the fish community and found no invasive species. There were trout. It was mostly suckers and bullheads. They're still there. And the brook trout in there as well. So if you want to know what an untouched real native Adirondack fish community looks like, you have an example from this, which might actually surprisingly differ from what a lot of people might have thought with from the accounts from the 1800s of sports people promoting the Adirondacks made it sound like a monoculture of giant trout. In this case, the community is more complicated than that. However, just a few years ago, 2015, Wolf Lake, in this case they're calling it Wolf Pond, suddenly changed color compared to, here's a brown lake nearby. It turned green, like pea soup. My wife and I went out in May, and the lake looked like this. It used to be super clear. I took some plankton samples through the summer. The clarity was tanked. There was a lot of Crococcus in there. Nowadays, there's some other taxa in there. The lake is still cloudy, not cloudy as this, but that's a pretty severe change for a lake that has no sewage inputs, no fishery manipulations, any of that kind of stuff. And it's still kind of a mystery as to what triggered it, but it has not gone back to what it was. One possible clue was found a couple of years ago by some other scientists, fisheries folks, who were taking samples, and when they pulled up, I don't know if it was a bucket sample or a net, they found these odd little globs of gelatin floating in the water. They're jellyfish, freshwater jellyfish from Asia. So this is a quiet invasion of lakes all around the world from these Asian freshwater jellyfish that are hard to see. They come and go, especially in the late summer. We don't know how they got in there, possibly on the feathers of waterfowl. But the point is, the human influence is penetrating even to our most remote, pristine waters here in the Adirondacks, even when they're gated and aggressively protected by places like SUNY ESF. So to leave you with this thought and then open up for comments and questions, it brings to mind another quote from Henry David Thoreau. And he said, a lake is landscape's most beautiful feature. He said it was Earth's eye looking into which the beholder measures the depth of his own nature. And we can certainly see the depths of our own nature in the lakes around us as they change, which is basically showing us the tremendous reach of the human presence on this planet. We're so numerous, our technology is so powerful, and we are so interconnected that we've become a force of nature, strong enough to change climates, the chemistry of the atmosphere, move species around, and alter lakes, even in the remote corners of the world. So the sooner we can adapt our worldviews to that new reality of humans as a force of nature, the sooner we'll be able to make the world a better place, not only for us, but for ecosystems like the lakes we care about. So I'll end here, say thank you again to the Watershed Institute for having me. And let's open up for some comments and questions. I'll stop the screen share.
Thank you very much, Curt. I think humans are a force of nature, that's for sure. And I think that's something that we all need to remind ourselves of. And I think you do a really great job of illustrating that. And so I've got a few questions. And folks, if as Curt is going through and answering some of these questions, if you want to continue to ask questions into the chat or the Q&A, we can keep it going for as long as we'd like to. But a couple of questions I have here for Curt. Sorry, I've got all these boxes. So this one's related to fall turnover. So I'll just read it. Does the increased temperature affect the fall turnover in the water layers, resulting in delay in time or not complete turnover?
Yeah, that's a really important question. And unfortunately, we do not necessarily have the monitoring infrastructure for that for a lot of lakes. Some of you are familiar with the research that goes on Lake Champlain, so you might want to chime in on this. But my understanding of, let's say, the monitoring of water quality and temperatures in Lake Champlain will sometimes end in the fall before the lake freezes, in which case the date of the fall turnover and mixing could actually be missed. So I have not seen evidence of that presented anywhere, but you would deduce that the shorter winter is and the longer summer is, the later the fall overturn ought to happen. We are seeing the warming of the water on our lake with those biology data. We're actually not seeing the turnover, the change in the plankton happen much earlier yet. So that's kind of a mystery, but it would be nice to design our monitoring programs to cover the full ice-free season, if not year-round, to catch these changes as they develop.
That's it. I just kind of glob onto that one, Curt. We have, so we maintain a fancy instrument in Upper Saranac Lake that profiles the lake four times a day, and we always want to keep it in there. It's floating, so it can't get locked up in the ice. But we try to keep it in there to try to get fall turnover, and we have yet to observe it. We get close, but we're out there. It's Thanksgiving, and we're the last boat on the lake, and we finally pull it off. But there's still some stratification that we're seeing and we've been 5 years. We still have yet to hit that. So I know Brendan Wiltsey. He's on the call, but he's not able to talk. But I believe he's involved in a effort with Mirror Lake, and maybe you're familiar with that, Curt, where they're going to actually have temperature sensors on buoys and let them freeze over. Yeah,
I've been hearing that. I think that's right, Brendan. Sorry you can't talk.
I can make him talk.
Oh, make him talk.
Go ahead, Brendan.
Gotta unmute.
Hey, yeah, so I don't know if you guys can see me, but I'm in a dark office, so you wouldn't be able to see me anyways. But yeah, we monitor year round on the lake, but every 2 weeks. So the exact timing of fall turnover is hard to determine. But this coming winter, a collaboration with RPI, we will have a buoy that we're going to let freeze into the ice. And we'll keep our fingers crossed that it's still floating and in the same location come ice off in the spring, but those sensors will record temperature every 10 minutes and every meter of the water column. So we'll be collecting data to help answer that sort of question.
Great, Brandon, thanks. Another question related to stratification, thermocline. Has climate change increased the average depth to the thermocline on the lakes you've studied?
Yeah, so again, I don't have access to a lot of that info. I think the Institute might actually have that, and people like Brendan. My specialty is to look at the sediments beneath the lake. So I look around for people who are doing these measurements, which are really, really important. So maybe I'll just defer again to Dan. Do you know if people anywhere have found that sort of thing? The only lake I know about is White Pond in Massachusetts, and that has not shown an obvious thickening of the surface.
Yeah, I can't speak to that directly. I don't know if Brendan has anything on that since he's on the call.
The only thing I would say is that one of the things we're seeing in some Adirondack lakes is because of the change in transparency that Curt described, we're actually seeing the epilimnion become narrower. So that's that upper warm layer, because the light cannot transmit as far through the water column. So the thermocline is in some cases moving up, and that's largely driven by that change in DOC, which is mostly driven by the recovery from acidification. But there's also the climate component, so it's hard to tease those apart.
Yeah. So you've got competing influences going on there. If it were nothing but warming and maybe calming of the winds or something, you might guess it's going to get thicker layer on top. And if it's getting murkier, the light can't penetrate, the heat gets absorbed in the shallow part of the lake and it gets thinner. So that might be why in some lakes you might not see a big change, because they're working at cross purposes.
Got so a lot of interest in the stratification.
Yeah.
So another question related. You indicate stratification as a negative for Adirondack lakes. I'm not sure if you did. How does nature handle these effects for lakes that normally stratify? They say like the Finger Lakes. Alternatively, can a shallow pond stratify? I noticed temperature levels in my 10-foot pond. What are warming trends doing to shallow ponds, if anything?
Yeah. So if you have a shallow pond, it doesn't take very long to stratify a little bit during the day, but it will often break down. The reason it doesn't necessarily stabilize, unless it's utterly calm, no mixing, no rain, no nothing, is there's not a lot of thermal mass there in the lake to hold that kind of a heat and stabilize it. So if you have a shallow pond, you may well feel warmer water on top, especially in the afternoon, and not so much down below. But then when evening comes, it tends to cool and the water mixes again, and that tends to rust the bottom layers, keep oxygen there from top to bottom. And so you won't necessarily get those sediment effects and the internal loading of the phosphorus like would happen. As far as whether this is good or bad or not goes, those are human value judgments, which we need to acknowledge as depending on what our opinions are. Like I was sort of half jokingly implying that Bear Pond was more fun to bring people to when it was crystal clear than it is now, because it was so spectacular, you know. But of course, a lot of it was because it was, you know, poisoned with acids. So this situation we're in, when we see ourselves as a force of nature, I think also forces us to rethink what is our role in the natural world, and acknowledge that what we kind of instinctively call good or bad things are really just our own value judgments. And we need to decide, you know, do we want our lakes to be acidic so we have some clear ones, or do we not want that? It's a whole new way of being a human being in the world. So I try to avoid statements like that. I instead invite us to rethink what is our role in managing lakes or letting them be, or any of those things.
That's great. There were a couple of questions on the good or bad that you covered with that answer, so I appreciate that. Question on algae. So how many types of algae bloom are there? And are there some that are a greater concern ecologically than others?
Yeah. So there are many, many kinds of microbe that can live in the plankton. There are multiple kinds of algae, from green algae to diatoms to chrysophytes and others like that. There's another category which looks much like the green algae, but are actually in another kingdom of life, the cyanobacteria. And people are usually more concerned if those are the ones growing in large numbers. Chrysophytes and diatoms can make the water look brownish, let's say. They can smell like dead fish sometimes. But if you get heavy growth of certain cyanobacteria, some of them can produce toxins, nerve toxins and liver toxins that can make the water unhealthy to drink. If there are heavy algae blooms, like often happen later in the summer in Lake Champlain, in some of these areas where a lot of phosphorus washes in, sometimes a beach will be closed so that you don't even want your pets going in there. So if you have that kind of phytoplankton growing because of the nutrients and the stratification, cyanobacteria are usually what people are most concerned about.
Thanks, Curt. Interesting question about aquatic plants. So how does browning or greening affect aquatic plant growth, particularly invasives?
Yeah, there's a close ecological connection to life on the bottom of a pond and life floating in the pond. Oftentimes a pond will have many kinds of native and sometimes even invasive macrophytes, you call them, basically just pond weeds of many kinds growing on the bottom. They depend on the sunlight to reach them, so they usually don't grow very deep, and they're rooted in the bottom. They'll draw nutrition from the mud. They're also drawing nutrition from the water sometimes too. So the trade-off for them is if the water starts to get murky, even if it's from browning, but also if you're putting extra nutrition in the pond and the plankton are getting the nutrients before the plants get them, then the clouding of the water will reduce the sunlight getting to the plants. I'll give you a specific example of why this could be a problem. It's from Walden Pond, which we've also studied extensively in Massachusetts, that Thoreau made famous. It's still pretty clear, but it's not so clear anymore because tens of thousands of people swim in it every year, and they release human waste into it and are part of the food web now. But there's another thing going on. It's still clear enough for there to be a lot of macrophytes. They're called nitella, that grow at sort of intermediate depths there on the bottom. But the big fear is if the waste and other things continue to pollute the pond, the water gets more murky. If those plants on the bottom get shaded out, then they're no longer down there making oxygen. And if you lose the oxygen production at depth, you get that same process of losing the iron cap on the sediments and also losing the plants that were pulling the nutrients out of the water so the plankton didn't get them. So there can well be a tipping point for lakes or ponds that have a benthic plant community and the phytoplankton community. As the water gets less clear, if you make it too murky for those bottom plants, you can not only lose their ability to soak up nutrients and get them away from the algae, but then do that internal fertilization from the sediments and set off more intense eutrophication, basically turning the biomass that used to be plants on the bottom into floating algae and cyanobacteria. So they definitely go together. And you need to know your lake and know what lives in it and what is the story and what are the processes at work that you might be concerned about. There's one right there, the interaction of plants and algae.
Thanks, Curt. Yeah, since we just talked about algae, there's a question: are there any invasive algae that we should be concerned about apart from the greening effect of native ? Algae?
Yeah, that's tougher. Brendan might want to chime in if he wants to add anything on this, but Microbes like that are so easily dispersed that they tend to be pretty much global, or at least hemispheric or latitudinally distributed. So some of the species I can find in Moody Pond, I've also found in Lake Victoria in Africa. So it's hard to really have invasive microbes in general, but what tends to happen instead is you change the physical structure, like with the temperature, or the chemical nature of the lake to favor certain species over others, so that as their propagules come in, they actually say, oh, this is nice, I didn't used to like it here, let's settle. And they can start to outcompete and replace the plankton that used to be there. So that's more of a concern. It looks like that's happening in Wolf Lake. When we take our sediment cores now, if you look in the youngest layers, there are more of certain kinds of chrysophyte algae than used to be there for thousands of years. And there's also a new one called Rhizoselenia, which I've never seen in cores around here, but I've been finding it in Wolf Lake. So not so much invasives, unless Brendan wants to correct me on that.
No. Okay.
Good.
Let's, we got a couple more minutes. Just a question about lake trout. Are lake trout an endangered species?
As far as I know, they're not officially an endangered species, but they are in danger. Mary Phil with the Nature Conservancy had done some really good work on compiling available literature on the status of lake trout around North America and Canada and the US. And they're disappearing for various reasons. Some of it is the warming and loss of the oxygen supplies down below, which again gets back to the Follinsby Pond case, where it's important to find the ones that have that deep water and protect them as refuges. But also pollution, the acid rain took out some. Most lakes that people can get to are managed, so-called managed, you know, putting your hands on it, putting in species that, you know, you want to catch, putting in other fish that compete with them, or unintentionally introducing other species as well. So if you add up all these multiple issues going on, lake trout are in big trouble in general. So if you do find a lake that's protected, like Follinsby Pond, and also deep enough to keep a deep refuge there, they're all the more precious now that we know what's going on long term.
Thanks, Curt. I think we have time for one last question. I think this is a good one. So you've been doing this research for a long time, Curt. You've learned a lot of things, and so this question is really relates to sort of action, I guess. So, is this research having an impact on policy, either at the state or local level? So I guess your experience with all that would be of great interest to share, I believe.
Yeah. Well, again, I'm gonna bail a little bit on that because I'm the guy who likes to go out and study the ponds, and to me, humans are more of a mystery than the most remote lake in the world. So I will say that you could reverse that question a little bit. The lakes here are changing because of policy that worked. Acid rain is an unrecognized, massive environmental success story that pulled the United States together with both state and federal legislation and policy that people worked hard to establish. It was done with bipartisan political support. Imagine that in those days. The industries responsible for the pollution helped design the policies. It did not hurt them that much economically, and it worked, and it's still working. So nowadays, when we often tend to be cynical about policy and things like that and not following science, we need to remember that we've done it before. We're still doing it. And if you have good science-informed policy, and then people willing with sincere intentions to make it work, we can actually do that. Again, on a smaller scale, I mentioned the Follinsby Pond situation where the Nature Conservancy is not only looking to protect it as a famous cultural and historical site, but also as a climate refuge. So there are stories like that happening around the world as people are realizing what's going on and what a role in it is. Maybe Dan, I don't know if you're more tied in with the policy stuff or somebody else, but I'm going to pass it on to you now.
No, I think you did it. I think you reminded folks of really a wonderful success story with policy, which was informed by science, right?
Yeah.
And supported by science to show that the policy actually made a difference. And I think that's, as scientists, we can kind of hold that up as a success, where we work together to really manage a serious problem. And I think that's well said. So it's 8 o'clock, and I know there are more questions, but what I'll do is I can go through and answer a lot of those. They're sort of peripherally related. It's hard to say that word, but I want to just I wish we could clap. I clap like this, but I thought it was really great, really great presentation, exceptionally well delivered, and just really great information. And I know if folks could clap, they would be clapping very loudly, maybe standing up. But thank you very much for joining us this evening, and thank everybody for